fabrics are fabrics that respond or change in a way that's useful. For example, it's cold outside and you want to stay warm, can the fabric help you do that? If you're wearing a mask, you should probably change it. Can the fabric or can the material that it's made of help you do that? Electrospinning is a way to make non-woven fibers. So these are fibers like paper towels or tissue paper or newspaper. You pump a polymer solution at a constant rate so that it makes a drop, and then you apply an electric field. That electric field pulls that droplet into a conical shape, and eventually the force due to the electric field overcomes the surface tension of the drop. Then a jet forms. That jet will travel from wherever you're pumping it to a grounded collector. As it travels to the collector, it gets whipped and stretched, and then during that process it shrinks from hundreds of microns, which is like the size of your hair, to as low as hundreds to tens of nanometers, and it's deposited as a non-woven mat of nanofibers. What we're learning so far is how we process them really affects whether or not they do change color. We need to carefully choose how we process them and what we put in at the beginning so that they maintain that functional, so that the liquid crystal remains like color changing once it's in the fiber. You can also think of them like really special mirrors that only reflect one specific wavelength of color, and that wavelength depends on what temperature it is outside. There are lots of different types of liquid crystals. So there are ones that respond to humidity, ones that respond to current, like electrical current. The possibilities are pretty limitless. The Army has some interest in basic research, so we're thinking about other classes of liquid crystals, so really tuning the colors that do appear, thinking about other types of stimuli. Working with the Army, thinking about, okay, now that you've shown that you can do this, how do we want to use it?